So for this problem, to find the sum of the series, since this given is an arithmetic series, so this is the formula to find the sum of the arithmetic series. Since from this given, this is the first term, the second term, the third term, and this one is the last term. Then from this formula, observe, we need to find the number of terms. So to find the number of terms using this arithmetic sequence formula, then substitute now all the values. So for a sub n, the last term, this is 130, then equals a sub 1, the first term, that's 4, then plus, and this one is the unknown, the number of terms, minus 1 times the common difference. So we can find the common difference using a sub 2 minus a sub 1, or a sub 2 is 13 minus 4 for a sub 1. So the common difference is positive 9. So this is times 9. Then to simplify, so transpose this to the other side. So this becomes 130 minus 4, then equals, so multiply. This is 9n. Multiply, this one is negative 9. Then this 130 minus 4, this is 126. Then equals 9n minus 9. Then this becomes 126. Transpose this negative 9 to the other side. So this becomes positive 9, then equals 9n. And this 126 plus 9. So we have 135 equals 9n. Then to solve for n, divide both sides by 9. So we have n equals, so 135 divided by 9. So 135 divided by 9. So that's 15. So therefore, there are 15 terms in the series. So since we have now the number of terms, so we can find now the sum of the series using this formula. So the sum of the numbers equals n. N is 15 divided by 2 times the first term, that's 4, then plus the last term, that's 130. Then this becomes the sum of the numbers, and 15 divided by 2, then times this 4 plus 130, this is 134. Then we have the sum of the numbers equals, so multiply this 15 times 134. So 15 times 134. So that's 2010. So this is 2010, then divide by 2. So to solve now for the sum of the series, so we have 2010 divided by 2 equals, so the sum of the series is 1005. So this is equal to 1005.